In today's lesson, we're going to discuss about three things: displacement, velocity, and acceleration. So let's start out with displacement and what it is. So displacement is a position with respect to something else. So in this case, you see a house. So here's a house, and then here is a car. Now the car right now is to the left of the house. When something is to the left of the house, in this case, it is negative. The displacement is negative, meaning to the left. Now, if the car was to the right over here, that means that the car's displacement with respect to the house is positive. It is positive, whatever that number is. So let's just say right now the car is 5 kilometers. In this case, the car is 5 kilometers positive to the right of the house. Now, if the car was over here, right at the house, the car is neither to the left or to the right. It is right at the house, meaning there is no distance between the house and the car. So that means in this case, the displacement is 0. So now let's talk about velocity. So velocity is, in terms of a car, it's related to speed, but with a direction. So let's have a look at this green car. So right now the green car is heading east. It's heading to the right. So what that means is the velocity, let's just say it's 10 kilometers per hour to the east. And when you have a car moving towards the right or towards the right, that means it has a positive velocity. So anything moving towards the right, to the right, is positive. And then sometimes the car could be going west. So going west is to the left. So notice the car is heading in the other direction. So it's heading west, heading west. So regardless what happens to it, the velocity is negative because it's going to the left. And what happens if the car is not moving? Just like right now. So in this case, the speed or velocity is 0, no movement. So let's recap this. So let's look at the negative. So when velocity is negative, that means the car is moving towards the left or west. If the velocity is 0, that means the car is stopped or not moving, so no movement. And when the car has a velocity of positive, that means the car is moving to the right or heading east. So now we're going to actually look at the 9 case scenarios here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and see what happens in each case. Let's look at the first one here. In this case, both velocity and displacement is negative. So what displacement negative means is the car is to the left. So right now the car is to the left of the house. And what's happening with this car, the velocity? Well, it's actually moving because it's not 0, and it's moving which direction? It's moving to the left. So what's happening? The car is to the left and it's moving to the left. And what's happening to the distance between the house and the car? Well, the car is moving away from the house. So in other words, this piece here means that the car is going to be moving away from the house. So I'm going to put here, away from the house. So now let's look at the next one over here, right over here. Well, the displacement is still negative, so that means the car is still to the left. But the only difference right now, the car is not moving. So what does that mean? Is the car moving away from the house or not moving from the house? Well, because the car is not moving away from the house, the car is just standing still. So in other words, we can write down in this box here, the car is to the left of the house, but it's just standing still or not moving at all. Okay. Now the next one over here is still the displacement is negative. The car is to the left of the house, but what's happening right now? Oh, the velocity is positive, meaning the car is going to be moving towards the right. So now we have the car to the left, but it's moving towards the right. So what's happening as I take this car and it moves towards the right? So it's moving. What's happening with respect to the house? Well, it is getting closer to the house. So in other words, this one over here is getting closer or moving towards the house. Now let's look at the extreme right column here. So extreme right column says the displacement is positive. So that means the car is to the right or the east of the house, but the car in this case right now has a negative velocity. The velocity is negative, meaning the car is going to move to the left. So the car right now is to the right, but now it's moving slowly, in this case, towards the house. In other words, it's getting closer. So in this case, it is moving closer to the house. And let's do this one over here, same idea. Well, the car, in this case, it's to the right of the house, as you can see in this picture, but the car is not moving. So it's just idling meaning it's just parked there, not moving at all. And what happens if it is plus? Right now, in this case, we have velocity being positive. Well, what that means is the car is going to be to the right. Notice how the position's to the right, but it's heading to the right. And what's happening in this case? Well, the car is moving away from the house. So I'm going to put here, away from the house. So let's look at the middle column right now. So the middle column says, oh, the displacement is always 0. That means it seems like the house is at a certain time at the house. So let's look at the center one over here. So over here, it says here that the car is, displacement is 0, it's at the house, and the car is not moving. So what that means is it's at the house. At the house, it's just idling, just parked at the house. Now, what about the top one here, in this case here? Well, the car is at the house, but the velocity is negative. Well, velocity negative means that the car is heading which direction? Over here. So it's heading towards, it's actually moving, moving left, but as it's moving left right now, the displacement is positive, but right at this moment, right over here, right here, is where the car is at the house, but it's still moving towards the left. So at that instantaneous moment, so again, over here, the car is to the right of the house, all right, and it's moving west, moving left, and right over here is where the velocity is still negative. The car's still moving, but it's just passing the house. So that's what that means. And vice versa over here for the bottom one here. So over here, all right. So right now the car is moving towards the right. So it's actually moving the right, but the displacement is not 0, but it's going to the right. But as it happens right now, the displacement is 0 and the velocity is still positive because the car is still. So basically what that means is the car is just passing the house at that moment. So I'll put here, it's passing the house at that specific moment. So here's a summary of all the relationships between the d and the v, displacement velocity. If you notice, when both d and v are negative, what that means is the car is moving away. And if you notice for the d and v to be both positive, in this case here, it's also moving away. Now, if d and v are opposite signs, so one is positive, one is negative, or vice versa, if you notice here, it's moving towards. And anytime when you have a neutral number like 0, it has a different case. It's neither moving towards or away. It's somehow passing through or parked at the house, give or take. And anything with 0 here, velocity is 0 here, it's just parked. The car is neither moving, it's just parked. So here we have a displacement over time graph. It's something that you may have encountered in advanced functions or maybe in grade 9, and basically tracking the position of the car. So if you notice here, in this case here, where the blue pen is, right over here, notice how this entire area here is all above the x-axis, meaning the displacement is positive. In other words, the car, and you imagine a house and a car, so here's the house. That means in this position here, the blue part here, the car is actually to the right of the house. So but here, displacement is positive, displacement is positive, displacement is positive. In other words, the car is over here. Okay, so imagine this is a car. Okay, all right. But if you keep on going with this graph here, in the green part here, I'll just highlight this in green. Notice the displacement is in the negative, it's below the x-axis. What that means is the car eventually, after a certain time, is going to be somewhere to the left. So imagine this is the car, okay? Whatever, all right? And also at this point here, what does this mean? Well, when the displacement is 0, that means the car is at the house. So another here, but here displacement is 0, but in green here, displacement is negative, negative and negative. Okay, now let's have a look at the velocity, whether the car is moving or not. So if you notice here, I'll use a different color. Over here, notice how the displacement is changing. Well, that means the position of the car is changing. It's not at the same spot, meaning the car is actually moving. The car is moving, so that means velocity is not 0. In this case, velocity is going to be how fast the car is moving. And if you to calculate the slope of this line here, the slope is going to be 3 choices: positive, negative, or 0. It's going to be positive because the slope is, the graph is going up. Over here, in this part here, the velocity or the slope is going to be 0. Because if you notice here, the car is still at the same position. It's still at whatever this number is. So it's not moving at all. And it's over here, it seems like the velocity is negative. The slope is negative. All right, the rate of change is negative. And what's happening? It seems like the car is actually moving from farther to closer. And over here, the car is still moving. So over here, notice here, the velocity, just because the car is at the house over here, it doesn't mean it's parked at the house, because if you notice here, there is still a change in displacement. It's not flat. So that means velocity is still negative over here. So velocity is still negative, but over here in this area here, as we move from here to here, notice that the position is still the same position, displacement. So that means the velocity is 0. And what happens afterwards? Okay, well, the velocity is positive. So in other words, I want to say that the velocity is the change in distance or change in displacement. In other words, velocity tells you something about the change in displacement over the change in time. Another fancy word for velocity is the same thing as, another fancy word for rate of change or instantaneous rate of change is the derivative of the displacement. In other words, velocity could be written as d over d, where this big D is the displacement, or it could be d prime. So let's recap this entire car's journey from the moment at the very beginning. So over here, the car is how far from the house? Well, the car is 2 kilometers to the right of the house. And what's happening in this first part of the journey? Well, the car is going to be, notice here the D is positive and the V is positive. When both signs are positive, based on the previous slide, it's going to be moving away. And even the graph actually tells you it's moving away. So the car is moving away, and then at some point it just stops. So it stops for a few minutes, and then after that, what happens? Oh, notice how the displacement is still positive. So the car is still to the right of the house. So reading the car is still here, but it's actually heading towards the house. Notice here the velocity is negative and the displacement is positive. When they're opposite signs, the car is going to be moving towards the house. The car over here at this dotted here is the car is passing the house. It's not parked at the house. It's just passing the house. And then afterwards, right now, the car is to the left of the house. So meaning the car is over here. The car is still moving west of the house towards the left. And eventually it stops. So the car stops and it's at the left of the house. And then eventually what happens here? Oh, after stopping, the car starts to move. But which direction is the car moving? Well, notice the D is negative and the V is positive. When the signs are positive, it is moving towards the house. And if you notice, the displacement is getting closer to 0. It is 0. It's going to get back to the house.